Hello, my friends. Let's talk domain and range and whether something is a function or not given a graph. So we remember that domain is our x values, while our range is our what? Well, it's the opposite, so it's our y values. We know that x values are left and right and y values are up and down. Cool, brilliant. So if we look at our first question here, we are given just plain old dots. We have never really worked with these before, have we? Oh, how exciting. So first I ask you if it's a function. Remember that functions are only contingent upon their definition. The definition being each unique input has a single output. The output itself does not have to be unique. So our x values in this case are our input. So we look at our x values, we go around, we look at each plot, we look at this plot. We go down. It's at -4. Are there any other plots at -4? Let me use a different color. Are there any other plots where x is -4? I do not think so either. How about this plot? This is at -1. Are there any other plots at -1? No, there is not. Cool. So far, so good. Right here, we have a plot at 0. It's at my origin. Is there any other plots at my origin? No, there isn't. So far, so good. At this next plot, we have it at +1. Nobody else is there. Brilliant. We have this plot at 5. Nobody else is there. Brilliant. Yes, this is a function. And I'm going to notate function with f of x because I don't want to write it all the way out. It's a little lazy of me, but it's fine. Domain, remember, it's my x values. Range, it's my y values. So for my x values, do I have any continuous lines here? Do I have any continuous lines? Do these points like line up? And do they have a line connecting them? Do they connect the dots at all? The answer is no. So my domain is only these x values that are given to me for these 5. They are only those. So I have -4. I have -1, I have 0, I have +1, and I have +5 for my x values. Same thing happens to my y values. I have no continuous lines. Nothing is connecting dots here, meaning I only have those specific plots. What's different about this line and these plots is that I have so many plots here, I can touch them. There's so many. Here, I only have 1, 2, 3, 4, and 5. They are specific. They are only those 5. Range, I look at them. I go here. I'm going to start from the bottom. I look here. I have 2 at -5. Remember, that is allowed. We just have to have any output. Inputs have to be unique. Y values do not have to be. However, you only write it once. I start from the bottom because I always want it to be the smallest number first. So -5. Then I will go over here. I'm at -3. I go up. I go over here. I'm at 2. I go to this point. I'm at 4. Brilliant. That is my domain and range for number 12. If we look at my line over here, I ask you, does it pass my vertical line test? Does it only hit one point at a time? Yes, it does. Yes, passes. VLT. Makes you a little hungry, doesn't it? Yeah. Anyway, domain, x values. Remember, my x values are left and right. Do they go on forever? Is there any point where my line stops? I ask you, is there any point where my line stops? No, it does not. It has arrows at both ends, meaning it goes on forever. Meaning we're going to be using infinity here for my domain. My domain is going to be -infinity is less than my x value because x is my domain, which is less than +infinity. Brilliant. And as a reminder, this never changes. My inequality part never changes for my domain as long as I have a continuous function this way. Again, this one didn't have any continuous things going on. It only has specific plots. So this is -infinity to +infinity. The range is also going to be the same kind of inequality. It's going to be also -infinity because it's going up and down forever. The arrows go on forever. So it goes from negative infinity. Oop, that is an 8. Negative infinity is less than y, which is less than positive infinity. And that is how you look at domain and range of a function for graphs. Thank you.